the video, we were working on this script to implement a supervised learning strategy to account for the direct reward. We were actually almost done, but because the result will require some kind of a more extensive discussion, so it might be better to just remake a different video. Before we get into the codes, let's just go through the disclaimer again. All examples and code presented in any of my YouTube videos are technical and illustrative in nature and do not represent any financial recommendation or investment advice. Right. But let's finish writing this code. We have trained our model. This line actually creates the model, right, with 2 hidden layers and then 64 hidden units per hidden layer, right? And then we normalized the training data, right? And then the entire training process happens on this line, right? When we call the fit function with the normalized training features, and then the normalized the labels that's computed based upon the direction of the price movement the next day, right? And then after the training, we want to test our data using we want to test our model using the test data, right? And this test data was never exposed to the training process, and we were normalizing this test data by using the average and the standard deviation computed from the training data, right? So how do we compute the cumulative return for this particular neural network based strategy, right? In order to compute the return, the first thing we have to do is to actually compute the position, right? The position is going to equal to np.where. So this time we'll have to use our model, this trained model, to make predictions. So model predict, right? And then what's going to be the input to the prediction, right? The input to the prediction is actually the normalized test features. So it's going to be test normalized codes. That's all the features, right? And the result of this prediction is going to be compared with what? It's going to be compared with 0.5, right? If you still remember the output of the sigmoid function, right? We talked about the sigmoid function in previous videos, but the output of the sigmoid function is a value that's between 0 and 1, right? So if it's larger than 0.5, then it's treated as a long position. That's called a 1. And then if it's smaller than or equal to 0.5, then we are treating it as a short position. It's going to be a 0, right? And that's going to be our position, right? Once we got the position, in order to actually compute the return of this entire strategy, it's actually quite straightforward. Let's just call it test ANR. The neural network return is going to equal to test position multiply with test RET, right? That's going to be the day-to-day closing price fluctuations, right? And then if we want to make a plot of it, so all we have to do is to ANR, right? First do a count sum, and then apply the np.exp function to it, and then make a plot, right? And then if we run this cell, we should be able to actually get a figure to show us the accumulative return of this neural network-based strategy, right? And that's this curve. Right? So this is the time period for the testing data. It goes from the January of 2019 to about the beginning of March 2021, right? And then the accumulative return is close to it's probably close to like a 5 point something, right? 5 point something. It's between 5 and 6. It's basically between 5 and 6. Do you still remember the accumulative return of that 2 moving average strategy that we have calculated in the previous script, right? That one. Do we still have that figure? I think yeah, we still have that figure, right? That was the cumulative return curve for the moving average strategy for the same time period, right? And the cumulative return is about 1.38, right? But here it's over 5. So it looks like this strategy is much better than this strategy on the testing data, right? On the testing data. So what does it mean, right? What does it mean? Is that really a better strategy? Is it, so this NN-based strategy looks like it's indeed better than the moving average strategy on the tested data, right? But is this a really good strategy? Is this a really good strategy? No, it's not. It's not a very good strategy because I know a better strategy. I know a better strategy that's gonna give you about the same returns for the same time period, right? And it's gonna involve less amount of transactions, less number of transactions, right? Less number of transactions. And that strategy is called buy and hold. How do I compute the cumulative return for a buy and hold strategy, right? So all I have to do is to add one more curve, which is just this curve, right? So if I just plot the cumulative return of this day-to-day closing price fluctuation, then what I'm gonna get is actually this this buy and hold strategy, the cumulative return of this buy and hold strategy. So this NNR, that's our neural network strategy, which is actively traded, right? You pretty much have to compute your position every day, and then either sell out your hold, your long positions, or just buy some stocks, right? So the orange curve NNR is sort of the actively traded strategy, but this blue curve, this RET curve, is actually based upon this buy and hold strategy, right? It's worse than this actively traded strategy, but it's not by a huge margin, right? The NN strategy is over 5, but this one is over 4, right? It's not really a huge discrepancy, right? And you have to consider the number of transactions that's involved. The number of transactions that's involved for the buy and hold strategy. It's just one transaction. You buy over here, and then just hold on to it. Never sell it out throughout the 2-year period, right? And then you can get a return that's close to like 4 times, right? It's actually more than 4 times, right? It's actually more than 4 times, right? If you do this kind of a actively traded strategy, you have to buy and sell constantly, right? And if you are using those some of those online trading platforms that don't have those transaction costs, this might not be a problem for you. But if your trading platform actually involves transaction costs, then all those frequent transactions or frequent buy and sell, it's gonna cost you quite a lot, right? You have to consider those transaction costs. And the second issue that might be kind of important is tax, right? Tax. If you don't sell out your stock, you're not gonna be charged with the capital gain taxes, right? But if you do this kind of frequent trading, there could be capital gain taxes that's involved. But again, this is a really complicated topic, and it's not really a good time to talk about those issues that's related to taxes, right? So there is a much simpler strategy that could give you about the same return, right? Could give you about the same return, which is the buy and hold strategy, right? Buy and hold strategy. This is quite discouraging, right? This is quite discouraging. All our calculations that involves tens of lines of code looks like it's not much better than this buy and hold strategy, right? Later on, I'm gonna talk about why I feel very encouraged by this particular result, right? It looks quite discouraging, but it's actually very encouraging. It's actually very encouraging. But before we talk about the upside of this calculation result, let's talk about some other issues. So this particular ticker symbol that we are actually experimenting with is TQQQ, right? It's TQQQ. It's 3 times leveraged QQQ that tracks NASDAQ, this index fund, right? is buy and hold this kind of a leveraged ETF a good strategy, right? Is that a good strategy? If you have traded stocks before, you probably know about this thing that's called volatility decay. Volatility decay, right? This kind of leveraged ETF are not really designed for this kind of long-term buy and hold strategy. It's not really designed for that. It's designed for short-term trading, right? Buy and hold for like just a couple of days, not like buy and hold for like a couple of years. It's not like that. You just if you're doing this kind of short-term trading involving a few days or something, then this kind of a leveraged ETF is the right tool, the right instrument, right? But if you are actually buy and hold a particular instrument for your retirement account that's gonna last for like tens of years, then this kind of a volatility decay is gonna really cost you, right? If you already know about this, then that's good. But if you are new to the market, how do you understand this volatility decay for this kind of a leveraged ETFs, right? The reason that you have this kind of volatility decay is because the price is not increasing monotonically. Sometimes it's going to pull back. Sometimes it's going to pull back to give you negative returns for some days, right? And this kind of a pulling back is going to cost you. It's going to cost you, right? How do you know that? How do you know that? So if you take this buy and hold strategy for the last 2 years, the cumulative return is about 4 times, right? It's about 4 times, right? Slightly more than 4 times. But if you look at the underlying ETF, which is QQQ, how large was actually the cumulative return, right? It's actually quite easy to check it, right? You just go to TradingView, right? So instead of doing TQQ, just do QQQ, right? So where is 2019? 2019 right here. Right? 2019 about right here, right? So this is a monthly candle bar, right? So every candle bar represents the price fluctuation within a month. It's not the daily chart that we were looking at before. This is a monthly chart, right? So 2019 is right here. That's about closing price about 169 or something, right? 169 or something. What's actually the price today? It's about 317 or something, right? So it's close to about doubling. It's close to about doubling, right? But don't forget, this TQQ is 3 times leveraged. In the right, it's a 3 times leveraged ETF. So you would expect that if the underlying symbol QQQ doubles, then TQQQ, this 3 times leverage, should 6 times, right? But the actual return that you got was actually 4 times. It's far short of 6 times. Isn't that right? It's far short of 6 times. Why is that? Why is that, right? Why is that? It's because of this volatility decay, right? So how do you actually understand it, right? So suppose TQQ, let's just consider like a 3-day price changes between TQQ and QQQ, right? So supposing day 1, the price of TQQ is A and the price of QQ is B, right? And in the second day, the price drops by 10%. So it's A times 0.9 now. It's A times 0.9, right? No, for QQQ, this is A times, but for TQQ it's not, right? For TQQ it's 3 times. So it's gonna be B times what? It's a 10% of drop in the QQQ, so it's gonna be a 30% of a drop for TQQ. That's 0.7, right? That's for the second day, right? Suppose on the third day the price rises back by 10% on QQQ. Then what's gonna be the price, right? It's gonna be A times 0.9 times 1.1 for QQQ. That's 10%. But it's 10% based upon what? It's 10% based upon a reduced value, right? You're rising up from a smaller value, right? But when you're actually having a drop in the price, you're dropping from a higher value, right? Right. And this kind of a scenario is actually amplified by using this kind of a leveraged ETF that's 3 times leveraged, right? So it now becomes 0.7, right, times 1.3. It's 3 times leveraged, so it's not 10%, it's 30%, right? Then what's going to be the end result, right? So it's 0.9 times 1.1. 1.1 times 1.1 multiply with what? 0.9. That's 0.99, right? So it's going to equal to 0.998, right? But what about this value? And this value is going to be 0.7 multiplied with 1.3. That's 0.91, right? So after this kind of a 10% fluctuation within 2 days, the price on the TQQ becomes 0.91 times B, the starting value. But for A, it's 0.99 times A for the QQ, right? And this kind of fluctuation is gonna reduce this kind of a long-term performance of this kind of leveraged ETF, right? So if you want to end up with more money, after tens of years of buy and hold strategy, it's actually better. It's actually better to just buy and hold the underlying ETF that's not leveraged, right? Instead of buying one TQQ, you just buy 3 QQQ. You buy and hold 3 QQQ, and after like 10 years or something, you could end up with more money than buying and hold just one TQQ, right? But is buying and hold QQQ really a good idea? Is that a really good idea, right? Is the buy and hold QQQ is a really a good idea, right? It's a really good idea. Let's look at QQQ. Is this monthly bar? Yeah, that's monthly bar. But let's look at its history for like a longer period of time, right? You sort of see this kind of big fluctuations. Right? Very big fluctuations, right? And this is the 2000 tech bubble, right? This is the year 2000. In the year of 2000, in the year 2000, there was a tech bubble that eventually bursted. You have this kind of very sharp increase in the previous month, and then you have this kind of very sharp decay, very sharp decrease in the stock price, right, for the next couple of years, right? And then it looks like it comes back a little bit, and then drops again, and then rises back up again, right? If you have bought QQQ at this kind of a price range during year around 2000, right, over the next 16 years, you're actually losing money. So when the price recovered to the pre-bubble level, to the highest point of the bubble level, that was in 2017, in the January 2017. So that's after 16 years. If you are buying and hold QQQ from 2000 to 2016, you are not really making any money in your retirement account if you are buying and hold QQQ. Right? That's a very long period of time, and there's almost nobody can actually look at their retirement account for like 16 years without increasing any kind of without getting any kind of a return, right? That's a very long period of time, right? So is buy and hold a QQQ a really good strategy, right? Is it really buy and hold QQQ a really good strategy? Is it a really good strategy, right? So if you actually look at the same period of time, but instead of looking at the QQQ, which is actually exclusively tech stocks, instead of QQQ, if you look at SPY, if you look at the SPY from year 2000, right, from the year 2000, suppose you buy at around 2000 at this particular peak, and then how long does it take to actually make you money? It's actually slightly shorter. it's 2013. Starting from 2013, you start to make money in your retirement account if you buy and hold SPY, right? It's a shorter. It's less than 16 years, right? But it's still a very long time. It's still a very long time, right? And that's SPY. SPY. But is buying and hold SPY, this kind of a broad market index ETF, a really good strategy, right? Is that a good strategy? It actually depends. It depends on in which country you're actually investing in, right? This is actually U.S. stock. This is all U.S. stock, right? This is the U.S. market. This is a broad market index for the U.S., right? Suppose you look at the same period of time for Japan. That's the Nikkei index. Let me see. Yeah, that's the Nikkei 225. That's sort of the equivalent of SPY, but it's for Japan. It's for Japan, right? In year 2000, it's about around this kind of period of time, right? Around this peak, right? And how long does it take to get you out of the, to get you to recover to the same price level? It took almost 20 years, right? Almost 20 years. This is 2020 now, right? My cursor is actually at the year 2020. Almost 20 years for you to actually recover the price level, right? And not by much, right? Up until now, right? And it's not just Japan. If you look around the world, many countries have this kind of broad market index, right? It's not just unique to Japan. Lots of countries have their broad market ETF index that looks almost maybe not exactly the same, but it's very different from the U.S. SPY index, right? So it depends upon in which country that you are living and in which country you are actually putting your money into to buy and hold, right? So is the buy and hold strategy really good? If you look back enough time, right, for enough years, I don't think buy and hold is actually the right strategy. It's actually the right strategy, right? So that's probably enough for this particular video. We talked enough about the discouraging results, right? What's actually so discouraging about this particular calculation, right? In the next video, let's talk a little bit about why I think it's actually quite encouraging for this particular calculation. It's really promising, right? Why I think it's actually really promising.